In your linear algebra class, you defined a linear transformation to be any function where you can plug in a vector, get a vector for an answer that satisfied two properties. It was pretty abstract for most people. The problem is that one of the most important linear transformations is linear transformation that takes derivatives. Now, we don't need that in Calc 3. Not that we're not going to take derivatives, but we don't need the linear transformation aspect of derivatives there. So the stuff we need, we can get by with a much simpler definition. And so what we're going to do is define a linear transformation to be any function where we plug in a vector with two components or three components, where what this linear transformation does is just multiplies that vector by some matrix full of constants. There are some very simple examples that we really have to have first. The first example I'd like to look at, and this is a really boring one. Now, how do I give an example here? Well, we just give an example by picking some matrix full of constants. And so what I'm going to do is just pick the matrix full of constants, zeros. Now we know how matrix multiplication works. This is just going to be 0 times x plus 0 times y, that's 0. This is 0 times x plus 0 times y, that's 0. And so this is the linear transformation that always gives the number 0, 0 for an answer. Now, by the way, well, we'll worry about that. The second example I want to look at is a really, really important one, but it's also trivial to think about what we want. And again, I just want to fill the matrix full of numbers. And the most important matrix we actually see in linear algebra is called the identity matrix. And we get a reminder here of why it's called the identity matrix. When I multiply this is going to be x plus y, so that's just going to be x. When I multiply 0 times x plus 1 times y, I get y. And so what does this linear transformation do? It plugs in a vector and gives that same vector for an answer, right? That's because this is the identity matrix. It's called the identity matrix because when you multiply by any vector, it doesn't change the other vector's identity. This is a cool one. We can actually start looking at the graph that looks boring as we're actually doing this. Let's look at one example, and then I'll have you try one. Again, just gonna put whatever constants I want in there at the moment. The constants I want in there at the moment, I'm gonna put 0, 1, 1, 0. That is a matrix that when you multiply by itself, it gives the identity. But this is a little bit interesting. I'm going to get 0 times x plus 1 times y, so the y goes up here. And I get x, 1 times x plus 0 times y, that's x over here. And this is the linear transformation that just switches the x and y components of the vector. That's not so bad. You should practice enough with these by making up your own matrices. Just put something in there, see what happens. One you might just practice with is something like 1, 2, 3, 4. It's complicated, but try working it out and see what happens.